Hello friends, I welcome you to the week 3 of automation in manufacturing. In this week, we will be studying various aspects related to selection and fabrication of the components which are required to build an automated system. In this lecture, that is lecture 1, we will be looking at the selection criteria which is there for the electrical and electronics components that are required to develop a mechatronic based automated system. Well, my friends, we have seen in our previous lectures, to build an automated system or to build an equipment which is based on mechatronics based system, it requires variety of components, and these components are electrical components, electronics components, mechanisms and machinery, that are the mechanical components, hydraulics and pneumatic elements, and the computer programming, that is the software elements. So, to build a system, we need to assemble all these components together, but before to assemble these components together, we have to select the appropriate or suitable component available in the market. So, for that purpose, there are certain selection criteria, there is certain procedure that we need to follow. Some of the components such as the mechanical components or mechanisms, we have to build in-house, we have to manufacture them at our shop floor. So, how to manufacture them at our shop floor, that we will see in the next lectures. In today's class, we will be looking at what are the criteria required for the electrical and the electronics components. Electrical and electronics components are the main components of a typical mechatronics based system that we have seen already in the disciplines of mechatronics. Various drives, various electrical drives, the microprocessor, signal conditioning devices, sensors, all these are the major constituents of a mechatronics based system design. But what is happening nowadays, there is rapid advancements is occurring in the development of these components. So, if suppose we are getting integrated chip or a microprocessor, we may get a better quality or we may get an advanced technology in that microprocessor within 6 months. So, there is a rapid advancement in the technology. We should consider these advanced components in our model. So, being the designer, being the engineer who is working on mechatronics based system, we should be in touch with the technological advancements of the variety of these components as well. The proper selection of these components is a challenging task. If we made a certain error in the component selection, it may be very dangerous to the entire design of the system. So, the improper selection or inappropriate component of our assembly of the automated system may lead to the scrapping of the entire design. We have to scrap the entire design or the product or the system. Therefore, we must be very careful in selection of these elements. Being the designer, we should have the fundamental knowledge of these components. We should know the specifications of these components. The designer must know the construction and the functionalities or working of these components, and that is the objective of this course, my friends. In this course, we will be learning the variety of components which are required to build such a system. So, after getting the fundamental knowledge of the components, the designers must come up with the exact parametric values of that element or the component. In addition to the exact parametric value that is required to purchase or to select that component, the designer also need to give the permissible tolerance levels. The designer is designing the element or component and he is coming with a certain value, but for that exact value the component may not be available in the market. So, for that purpose the designer should have some tolerance that are specified on the exact parametric value of the component that to be selected, so that the purchase engineer or the selection engineer, we will go to the market, we will search the market and we will get the component which is giving the value in the permissible limits, that is the tolerances. So, nowadays we are using the web based technologies. There are a lot of web based parametric tables are available. So, we should go through these parametric tables available. Online catalogs are available. The catalogs are having the required information, they are having 3D visualization of the components, they are having videos of the performance of the components, they are giving the applications, some case studies. So, all these relevant information is available on the net, on the internet. So, being the designer, it is our duty to extensively go through the literature available of the concerned components, catalogs, and then select the appropriate one. In addition to these web based parametric tables and catalogs, there are a lot of forums which are available, online community forums which are available. The volunteers or the expert people will give their opinions, will answer the queries which are asked by the community members. So, to carry out the selection process or to carry out the selection of this variety of components in industry, a special team will be created and the special team will have the experienced engineers. Those will look at the web based parametric tables, catalogs, and they will interact with the online community forums, or they may even go to the market and try to get the components. Now, what are the various parameters that we need to consider during the selection of these atoms? The first parameter is the affordability, the cost which is directly affecting on the economics of the product design and development. So, affordability, we should have the components which are affordable to us. Of course, it does not mean that we should go for a very the low quality, less expensive components. So, there should be a trade off between the cost and the quality. So, there should be the optimization of the cost with the quality of the product. That is why it is called as an art. So, we should have the balanced decision. So, with minimum possible cost, we should get a good quality component, because the cost of the component is directly affecting the cost of the product or automated system. The next point is the reliability. We will see what is the meaning of the reliability. Then the life cycle or the product life cycle of the individual components, mechanical parameters, environmental parameters, and the electrical parameters. We will see the meaning of all these aspects one by one. The first aspect is reliability. So, reliability is defined as the probability that a product or system or service will perform its intended function adequately for a specified period of time, or will operate in defined environment without failure. So, reliability of a product is nothing but its performance for the intended function. So, how the product is performing its intended function adequately for specified period of time. So, when we are purchasing certain component, when we are purchasing some product or the commodity, so it is mentioned there that for how long the product would be working in its normal condition. Moreover, the product should work in the defined environment without failure. If suppose we are taking a product for certain condition, they say the shop floor where the conditions are very harsh, there would be noise, dust. If the sensor or if the component is not able to work under these kind of harsh conditions which are specified, then it is not advisable to go for purchase of such products. Or in short, we can say the quality of components performance over a period of time, that is nothing but the reliability. Why we should consider the reliability during the selection of the atoms? The reliability factors are helping us to determine the warranty and safety durations, as well as they are helping us to perform the decisions on design substitutions. The final automated system is constituting a variety of elements, and the warranty of service of the final equipment that we will be developing and selling into the market, its success is dependent upon its constituent elements. And we are outsourcing these elements, we are purchasing these elements from the market. So, if the elements or if the components are reliable, then and then only our product will be reliable. Moreover, the product safety is also dependent upon the proper functioning of these elements. If one of the element will malfunction, it will definitely affect the safety aspects of the product. The next parameter is product life cycle. So, we have seen the concept of product life cycle in our previous lectures. The product life cycle is defined as the time duration between the start of the development of the product till its decline of sales in the market. The components which we will be purchasing from the market, they are also having a life cycle, they are also having a stipulated time to survive in the market, because of course the technological advancements or the change in choices of the customers. Simple example is the semiconductor IC chips. So, with technological advancements, we are getting the higher versions or the better versions of the IC chips. So, when we look for the mass production of our product, we should be able to consider, or we should consider the life cycle of the selected IC chip. For how long these components will be available in the future? That is a fundamental question. If the IC chips availability is not there, the IC chips are abundant in the market, these are not available, then we are not able to manufacture our product. So, we have to change the design of our product. So, that is time consuming. So, in view of this, we must take into consideration the life cycle of the product that we are selecting, that we are purchasing from the market. Therefore, we should go for a low risk and long life components. So, when we purchase a long life components, naturally the risk of failure or the risk of losing the time of development of our product will be low. The next set of parameters is mechanical parameters. So, the mechanical parameters suggest or they indicate the physical form of that element or the component. The physical form designates the size, shape, color, texture of that component or the element. Next point of mechanical parameter is mounting styles. How the component is getting mounted. What is the mounting style of the available product in the market? So, is it mounted on a certain fixture, whether the component need a fixture to fix it in the assembly, whether the component is hanging, how many fasteners are required, whether the mounting is the robust. So, all these aspects are coming into the mechanical parameters. The next mechanical parameter is the weight of the component. Of course, we need to have a component with low weight, the component should be light, otherwise weight of our product would be very high, which is not advisable, but it should have the sufficient inertia. The size, shape, weight and mounting style are helping in proper analysis of the connection of these elements in the assembly. So, we should consider the mounting style, the size, shape and the weight in a proper way, so that the assembly would be easy and the product construction would be simple. It will have low maintenance. As the number of components are less, the assembly is less complicated. It would be easily assembled, so that the customer can easily assemble the components. So, the ceiling fan, a simple example, that is a ceiling fan. So, we can easily assemble the ceiling fan and we can easily mount it wherever required for the domestic applications. So, if you look at its various parts or the mountings, mechanical elements, they are very simple. A layman can easily assemble it. The next set of factors or the parameters is the environmental factors. The intended automated system may be utilized for variety of purposes. It will be utilized for a variety of applications, say domestic application, or it may be utilized in the industry, or it may be a special purpose product. So, what is the meaning of special purpose product? The product may be utilized in biomedical instrumentation, it may be utilized for aerospace applications, say it may be a part of a satellite, or it will be utilized for defense applications. So, when the special purpose products are to be developed, then we have to consider the extreme conditions, extreme weather conditions under which these products are being utilized. For example, the aerospace products are working at a entirely different working conditions. The gravity will not be there, the temperatures or the pressures are entirely different. So, all these factors need to be considered during the development of the product. Same case with the biomedical applications. So, when we select the components for biomedical applications, we should consider the sensitivity of the elements, the humidity level or the temperature under which these all equipments are being utilized. In defense level applications as well, so the weather conditions may be very harsh, even at the shop floor, when the vibrations are very high, or if you consider a typical example of forging. So, forging application, when the noise levels are very high, when temperatures are very high, So, all these parameters are need to be considered when we select the constituents of the automated system. So, these special purpose automated systems may be utilized in a extreme weather conditions. The temperature ranges may be extended, there may be thermal shocks and extreme vibrations. So, when we know that the products may lead to such kind of extreme weather conditions, its constituting elements should also able to withstand these extreme weather conditions. So, in addition to thermal shocks and vibration, the humidity and the moisture that also are affecting the performance of this automated system. So, these are to be considered. Then some of the products may have the exposure to radiation in case of the nuclear applications. This equipment may be utilized for carrying out some the operations where the chances of radiation may be there. So, the components should able to withstand these effects as well. The next set of parameter is the electrical parameters. So, electrical parameters can be grouped together into the primary specifications. The primary specifications are nothing but the parameters which are directly controlling the functionality of the component. The resistance value, the capacitance value, memory width and cutoff frequency are some of the examples of these primary specifications. However, there are certain specifications which are generic in nature. For example, the operating temperatures or the voltages, which are almost applicable for all sort of component categories. As we know that the constituting elements of a mechatronic based systems may require the electrical energy to get operated. So, of course, there may be certain generic parameters associated with them, and these are the temperature and the voltage. So, the temperature requirement, in which temperature range the component is able to work, and what are the voltage requirements to operate that element or the component. The designer should have the proper knowledge about the primary specifications as well as the generic specifications of these constituting elements. So, let me summarize. In this lecture, we have seen how to select the electrical and electronics components, what are the various selection parameters such as the mechanical, environmental, reliability related parameters, product life cycle and the electrical parameters. So, my friends, these are the parameters that we need to consider when we select the components for the intended purpose, that is design and development of an automated system. Well, in the next lecture, we will be looking at the technical aspects of the electromechanical systems. There are various terms which are used in the selection of various, there are various terms related to the performance of these electromechanical systems. We will study them, we will understand the meaning of these terms, we will see a variety of examples to understand these terms in a better way. These terms are very much useful in the proper selection of these constituting elements for a better automated system design. Thank you.